Good afternoon, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. Today we will continue with the Trivariate Econometric modeling. In the last class we have discussed briefly about this Trivariate Econometric modeling, where there are three variables in the systems. One is dependent variable as usual in the case of bivariate modeling, and two independent variables. So now here our objective is to fit a econometric model where y is the dependent variable and two other independent variables called as x1 and x2. Let me first briefly highlight, then we will proceed for its discussion. So let us assume that y is consists of a sample observation y1, y2 up to yn, then x1 consists of x11, x12 up to x1n, and x2 involves x21, x22 up to x2n. Okay. With this basic background, our objective is to trace x1 and x2 on y. Okay. So we like to trace the impact on this is x1 and this is x2. Obviously, we have support variables, u variables, that is which we could not able to capture, that we will represent in the form of u. So now we like to know how is this setup and structure in the case of Trivariate econometric modeling. So briefly, if we put it in a mathematical form, then the econometric model is all about like this: y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus u error terms. So this is how the you can say econometric model econometric model is all about. So here I will put subscript I, so x1 I, this is x2 I. Okay. So let me put it in a other way. So here the model will be yi equal to beta 0 beta 1 x1 I plus beta 2 x2 I plus u. So this is put it equation number 1. Then our objective is to fit the estimated model. Okay. So obviously let us assume that the estimated model is a beta 0 head plus beta 1 head x1 plus beta 2 head x2. Okay. So then next step is we have to design the error component. Error component is nothing but y minus y head. Okay. So the moment we will get y error component, which is the difference between a original setup and the estimated setup. So this is nothing but y minus not y bar, it is y head. Okay. Y bar is a mean, but here we have to subtract original with the estimated value. So now here our objective is to have the estimated value of beta 0 head, beta 1 head and beta 2 head. So now how do we do that? So we have to go for error minimization. The way we will minimize the errors, then automatically we will get the value of beta 0 head, beta 1 head and beta 2 heads. So as usual, you know, to minimize this error sum squares, we have number of techniques like OLS, GLS, WS, MLE. So here you know, the way we have discussed in the case of bivariate econometric modeling. So in the case of Trivariate econometric modeling, we will also apply the ordinary least squares method, that is OLS technique, to get the or to estimate the way we will apply the OLS technique. Then we can able to minimize the error sum squares, and by the process we will have the estimated values of beta 0 head, beta 1 head and beta 2 heads. Let me here. So we will design the way how we have to receive all these items. So here, so first track is to have the error sum square. So E square I equal to 1 to n is equal to summation y minus y head, so which is nothing but beta 0 head plus beta 1 head x1 plus beta 2 head, so I think beta 2 head x2. Okay. So this is this is otherwise like this. So this is squares I equal to 1. So what we will do, we will simplify. So which is nothing but summation y minus beta 0 heads minus beta 1 head x1 minus beta 2 head x2, then whole squares I equal to 1 to n. So this is what we call it is summation e square. So summation e square is this much. So now this is the starting process through which we have to minimize the error sum square. So now we will move how we have to minimize the error sum square. So by the way, so there are 3 parameters. So that means summation e square equal to summation y minus beta 0 head minus beta 1 head x1 minus beta 2 head x2 whole squares. Okay, I equal to 1 to n. This is also I equal to 1 to n. All right. So now our objective is to get beta 0 head, beta 1 head, then beta 2 head. Okay, so these are the 3 specific objectives. Okay, there are 3 specific objectives to have the estimated value of beta 0 head, estimated value of beta 1 head, and the estimated value of beta 2 heads. So now accordingly we have to apply the Euler's technique, and the way we will minimize, then obviously we have to touch the necessary condition and the sufficient condition. The necessary condition is nothing but the error sums, means we have to differentiate the error sum square with respect to beta 0 head, beta 1 head, and beta 2 head. Then we have to go for the solution of these 3 equations, and by the way we will get beta 0 head, beta 1 head, and beta 2 heads. Let me explain how is it all about. So now, so first condition is, first order necessary condition is that, so d summation e squares by d beta 0 head is equal to 0, d beta 0 head is equal to 0. Then if you will go for simplifications, so then obviously it is nothing but 2 into summations, 2 into summation, okay, 2 into summation y minus beta 0 head x1 minus beta 0 head beta 0 head x, beta 0 head, and beta 1 head x1 minus beta 2 head x2. Okay, so this is beta 0 head. So this is beta 0 head means minus 1 has to be multiplied. Okay, if we simplify, then d summation e square by d beta 0 head is equal to means it should be equal to 0. Then if we further simplify, then it is nothing but summation y is equal to n beta 0 head minus it will obviously plus because summation y is coming this side. So beta 1 head summation x1 plus beta 2 head summation x2. Okay, so this is equation number 1. Okay, this is equation number 1. So now next step is we have to solve d summation e square by d beta 1 head. So d summation e square by d beta 1 head means it is 2 summation into y minus beta 0 head minus beta 1 head x1 minus beta 2 head x2 into this is beta 1 head. So it is minus x1 is equal to 0 So now if we simplify this particular equation, so then we will have summation yx is it is summation yx1. Okay, summation yx1 is equal to beta 0 head summation x1 plus beta 1 head summation x1 square plus beta 2 head summation x1 and x2. Okay, so this is how the second second solution for this particular minimization. So this is equation number 2. Okay, this is equation number 2. So now now we have to differentiate with respect to beta 2 heads. So that means d summation e square by d beta 2 head is equal to 2 summation y minus beta 0 head minus beta 1 head x1 minus beta 2 head x2 into minus x2 which is equal to 0. This is third equation. So now we will simplify this third equation, then we will have summation y x2 summation y x2 is equal to beta 0 head summation beta 0 head summation x2 plus beta 1 head summation x1 x2 beta 1 head summation x1 x2 plus beta 2 head summation x2 squares. Okay, so this is third equation. Okay, so now what we will do, so the process is in this minimization by OLS technique. So step 1 process is d summation e square by d beta 0 head is equal to 0, d summation e square by d beta 1 head is equal to 0, and d summation e square by d beta 2 head is equal to 0. So now if we simplify, then we have three different equations corresponding to beta 0 head, beta 1 head and beta 2 heads. So now if we club together, so then this particular problem will be in the form of 3 into 3 format. So that is this simultaneous equation of order 3, where there are 3 parameters and there are 3 equations. So this system is very consistent and we can able to get a solution. So what is this particular structure? The structure is here. If I will club all these 3 equations, then it will be coming like this: summation y equal to n beta 0 head plus beta 1 head summation x1 plus beta 2 head summation x2. Okay, so then summation x1y is equal to beta 0 head summation x1 plus beta 1 head summation x1 square plus beta 2 head summation x1 x2. Okay, so then third equation is summation x2y is equal to beta 0 head summation x2 plus beta 1 head summation x1 square plus beta 2 head summation, sorry, this is x1 x2, this is x1 x2 and this is summation x2 squares. Okay, so this is nothing but 3 into 3 equations. So we can also put in like this particular structure we can write like this: y equal to x beta plus x beta, simply you can say x beta only, y into x beta. Okay, so what is y here? So y represents here summation y summation x1 y summation x2 y. Okay, so this is y, and corresponding to this y, x represents n summation x1 summation x2, then summation x1 summation x1 squares summation x1 x2, then summation x2 summation x2 x1 summation x1 squares. So this is x, and beta consists of beta 0 head, beta 1 head and beta 2 head. Okay, so now so this is nothing but y equal to x beta. So if we multiply x inverse both the sides, so then we will get the solutions beta equal to x inverse y. Okay, x inverse y. So that means, so we will simplify this particular 3 into 3 model in a matrix format, and it is easy to handle this particular problem. The entire structure is almost all same now, like bivariate econometric model. So in the bivariate econometric models, we had 2 into 2 systems. So where our objective is to get only alpha beta, or if we reduce it this trivariate to bivariate, then the 2 parameters are beta 0 head and beta 1 head. Okay, so now in order to simplify all these procedures, so how we will get all these equations? So now if I will simplify, then I will get beta 0 head is equal to the matrix summation y summation x1 summation x2, okay, then summation x1 y, then summation x1 y summation x1 square, then summation x1 x2, then summation x2 y, then summation x1 x2, then summation x2 square. So this is beta 0 head, beta 0 head equal to this divided by matrix A. So A is nothing but A n summation x1 summation x2 summation x1 summation x2 summation x1 x2, sorry, this is x1 squares, summation x1 square, this is summation x1 x2, this is summation x2 x1, this is summation x2 squares. So this is how beta 0 head value. So now beta 1 head is equal to n summation x1 summation x2, then summation y summation x1 y summation x2 y, then summation x2 summation x1 x2, then summation x2 squares, okay. So this divided by n summation x1 summation x2 summation x1 summation x1 squares summation x1 x2, then summation x2 summation x2 x1, then summation x2 squares, okay. So this is what all about beta 1 head, okay. Similarly we will get beta 2 heads. So beta 2 head is equal to n summation x1 summation x2, then summation x1 summation x1 squares summation x1 x2, then summation y summation x1 y, then summation x2 y, okay. This divided by n summation x1 summation x2 summation x1 summation x2 summation x1 square summation x1 x2, then summation x2 x1, then summation x2 squares, okay. So this is the beta 2 value, okay. This is the beta 2 value. In order to simplify the entire procedures, so we have to apply the trick how to get the quick solutions. So far as this is how we have to derive the process to get the beta 0 head, beta 1 head and beta 2 head. So far as a classroom problem is concerned, it is required to know how it is coming exactly, the value of beta 0 head, beta 1 head and beta 2 head. But when we will handle this particular problem through any statistical softwares, then you just your job is very simple. Just you have to give a command, what is the dependent variable and who are the independent variables, okay. So here we are writing y, x1 and x2 for our simplicity only, so that the it is very eye catching and it can easy to understand, easy to justify or easy to represent. But when we have a practical problems, any finance problem or any business problem, so obviously your problem setup is all about with respect to three variables for this particular trivariate econometric modeling. So now what you have to do in this particular format, if there are three variables and three different names are there, for instance last class we have discussed when there is a bivariate models. So we restricted our model to say stock price versus foreign exchange, okay. So that means we are very much interested to know how forex influence the stock price, keeping stock price is a dependent variable and forex is an independent variable. So now we will add another extra variable in this particular nexus between this stock price and foreign exchange. So let us assume that there is another variable called as inflation, which can influence the stock price, okay. So now we practically will take that, let us say y is a stock price, okay, y is a stock price, then x1 is nothing but forex, okay, then x2 is nothing but you can say inflation. So here our agenda is, so this stock price is, it has to be integrated with the forex, okay, integrated with the for x, okay, then inflations, okay. So I will call it INF, okay. So now on this idea is here. So to know how much influence forex influence on stock price and how much inflation influence on stock price. So this is how this is this is one of these typical examples under Trivariate modeling, because stock price is a component which can be influenced by multi number of variables, and at a particular point of time it is not possible to identify, or it is not possible to represent so many variables altogether. So with respect to our specific problem, or so far as the Trivariate Econometric modeling is concerned, we are just restricted the stock prices versus forex and inflation. So now if you use the statistical subtiers, then obviously in 3 different columns you must have informations, okay. So like this. So we have y, x1 and x2. So corresponding we have already identify what is y, what is x1 and what is x2. So now you must have information like y1, y2 up to yn. Similarly x1, x2 up to xn. Then x11, x21, x11, x21, xn1. Otherwise you can put x11, x12, x1n. So that is better. So this is also x21, x22 up to x2n. Okay, this is how the representation is all about. So that means we must have a sample information with respect to stock price, with respect to forex, and with respect to inflation. So now we like to know what is the variation of forex and stock inflation on stock price of this particular, you can say, sample observations. So now when we handle this particular problem through any statistical software, then in each there are 3 columns in a particular setup. So for 3 column may be stock price, forex and inflation. So there is no hard and fast rules that you have to start with the first stock price entry, then inflation entry, then forex and forex entry. So it is not hard and fast rules. You take any variable entry in sequence. Then since we have already designed here models where stock price is the dependent variable and forex, inflation are independent variables, then obviously, so we have to, when we will go for this statistical software use, then we have to just give a command what is the a dependent variable. So if we will give indication to stock price dependent variable, then obviously other 2 variables we have to put in an independent variable structure. Then altogether you automatically get the beta 0 head component, beta 1 head component, and beta 2 head component. So now beta 0 the estimated value of that is, these are all estimated values of beta all betas, like beta 0 head, beta 1 head, and beta 2 head. So now here beta 0 head is represented as a supporting component, that is what we will call is a intercept in bivariate models. So beta 1 is the influence of, let us assume that x1 is forex, then it is influence supporting component forex to stock price. Similarly beta 2 head is the influence of inflation to, you can say, stock price. That means beta 1, beta 2 is the weightage factor, the influence factor to the stock price. So now this is very easy when we handle the softwares, but in the time being when we are in the classroom problems, so you may not allow you may not be allowed to go through any statistical softwares. Of course, what you can do, at best you can use Excel sheet for for your simplicity. So so far as a classroom problem is concerned, so there are 2 ways you have to handle very quickly. Some tricks you have to apply, and second thing, either you can use supporting component Excel sheet, or you can say another supporting component, say any scientific calculators. Okay, so let us assume that you are in the classroom, then how quickly you can finish this particular process. So we have already discussed what is the entire structure of beta 0 head, beta 1 head, and beta 2 head, and further simplified to make it more quickly. So we will transfer this structure into other different formats. Okay, let us highlight that issue first, then we will move to further structures. So here, so what we have received 3 equations: summation y equal to n beta 0 head plus beta 1 head summation x1 plus beta 2 head summation x2 then summation x1y equal to beta 0 head summation x1 plus beta 1 head summation x1 squares plus beta 2 head summation x1 x2. Okay. Similarly, summation x2y is equal to beta 0 head summation x2 plus beta 1 head summation x2 x1 plus beta 2 head summation x2 squares. Okay. So this is how we have three different equations. Okay. This is altogether three different equations. Okay. So now what we have to do, like you know, in the bivariate regression models, so we have also two equations because there are two parameters in that particular structures. So what we did in the bivariate structures, so in the first equation you divide n both the sides, then you know very easy way you will get this you know supporting component intercept you know estimate value. So that is here beta 0 head, in that case it is alpha head. So what you have to do, so you just here you have to just you know divide n both the sides. Okay. So now if you divide both the sides, then summation y by n equal to n beta 0 head divided by n plus beta 1 head summation x1 by n plus beta 2 head summation x2 by n. Okay. You know here n represents number of sample observations. So now if you simplify, then this summation y by n is equal to y bar. Okay. Y bar, this n cancel, so it will give you beta 0 head plus beta 1 head summation x1 by n is nothing but x1 bar. Okay. Then beta 2 head is summation x2 by n is nothing but x2 bars. Okay. So this is how the you know transformation. So now we need beta 0 head. So beta 0 head is nothing but y bar minus beta 1 head x1 bar minus beta 2 head x2 bars. Okay. Beta 2 head x2 bars. This is we will get beta 0 head. Then what we have to do, we need to calculate the beta 1 head and beta 2 head. So now if we put this particular equation in equation number 2, now using this particular structure in equation number 1 and equation number 2, and you simplify this particular equation 2 and equation 3, you will get simply summation x1y is equal to beta 1 head summation x1 squares plus beta 2 head summation x1 x2. Okay. Similarly, summation x2y is equal to beta 1 head summation x2 x1 plus beta 2 head summation x2 squares. Okay. So there is a difference here. This is another structure, this is another means this is first structure and this is second structure. So in this particular structure the variables are in deviation format. That means here where x1 represents x1 minus x1 bar. Okay. Then x2 so deviation x2 is nothing but x2 minus x2 bar. So similarly with the help of this we can calculate this summation x1 square, that means it is nothing but x1 into x1. So similarly if we multiply x1 and x2, you will get the summation x1 and x2. So that means what is the speciality is that, so when there are means when you are in the classrooms and you have a trivariate problem, so first agenda is to have the simple structure, means you have x1 x2 x3. So sorry, you have y x1 and x2. So you very quickly you can have summation y summation x1 summation x2. Okay. So like this. Okay, just I will highlight here. So now you have the sample setup like this, y equal to y x1 and x2. So corresponding to y you have y1 y2 up to yn, this is corresponding to x1. So you have x11 x12 then x1n. Okay. So corresponding x2, so you have x2 x21 x22 then x2n. Okay. So now quickly what you have to do, you will find out here summation y summation x1 then summation x2, and obviously n must be known to you. Okay. Then then again very quickly you must have another column x1 square, then you must have column x2 squares, then you have x1 and x2. Okay, so these are the essential requirement. So obviously there is some items here. So if you process all these items, then there is this gap can be filled up by this information only. So if you put all these in Excel sheet, very quickly you have to receive all these items. So now what is the idea behind this setup? So idea behind this setup is to have this is summation x1 square, okay, then summation x2 squares, okay, then this is this is not x2 bar, this is x2 squares, then this is summation x1 and x2. Okay, so now either you have this first, then you transfer into deviation format, like summation we have summation y square like this, summation y square equal to summation y square minus ny bar squares. Okay, so like summation x square equal to summation x square minus n x bar squares. Okay, so this is what we have already done in the case of bivariate analysis. So similarly we can also have here. So here instead of here we have the format summation x1 squares. So x1 squares, so it is nothing but summation x1 squares minus n n and this is x1. Okay, summation x1 square minus n into x1 bar squares. Okay, this is how we have to derive. Okay, similarly summation x2 square is nothing but summation x2 squares minus n x2 bar square. So this is how we can transfer all these issues. Otherwise the second procedure is you have another columns, like this is small x1, this is small x2, this is x1 and x2. all right, this is x1 and x2. So this this you take x1 square, this you will take x2 square. That means it is the question of x1 into x1, x2 into x2, then x1 into x2. So this x1 is nothing but x1 minus that means this is nothing but x1 minus x1 bar. So now you have to create a column small x1, that is deviation x1, which is nothing but the difference between x1 minus x1 bar. So you first create that particular column, then again that column if you multiply with the same element again, then you will get x1 square. Similarly you will create a x2 small x2, then you multiply again with that small x2, you will get x2 square. So now you have to multiply x1 small x1 into small x2, you will get the sequence x1 and x2, then you get the summation of all these items. So the moment you will get all these items, then the problem is a little bit simpler. So now, so for the as usual in the bivariate structure, in this trivariate structure, it is better to have first beta 1 head and beta 2 head, then you use that beta 1 head beta 2 head in first equation, where beta 0 head equal to y bar minus beta 1 head x1 bar and minus beta 2 head x2 bar. So the moment you will use beta 1 head and beta 2 head in that particular equation, so you can able to get the beta 0 head. So the first and prime condition in this particular process is to have the beta 1 head and beta 2 head. So now if you will simplify the deviation format, then the beta 0 head calculation is a little bit more easier. So now if you will apply that particular equation, means this particular setup is here. So if you will simplify this particular structure, then ultimately, so beta 1 head is equal to summation x1y, summation x2y, then summation x1 x2, then summation x2 squares. So this divided by summation x1 square, summation x1 x2, then summation x2 x1 and summation x2 square. So this is how the derivation of beta 1 head. Similarly, beta 2 head is equal to summation x1 square, summation x2 x1, then summation x1y, summation x2y. Okay, so this divided by, as usual, summation x1 square, summation x1 x2, summation x2 x1, then summation x2 squares. Okay, so this is beta 2 heads. So now here obviously summation, that means the in the note you have to write like this: summation x1 y is equal to summation x1 minus x1 bar minus x1 bar into y minus y bar. This is how you will get the summation x1 y, or you have to apply the deviation formula. Okay, so directly you can assess. So that means so you have actually y x1 and x2. This is what we call it original information, and can be represented in the form of capital Y, capital X1 and capital X2. Okay, so then if you don't like this deviation format, or if you are not able to remember this deviation format, so in Excel sheet you create three other variables like small y, small x1 and small x2. So small y is represent here deviation format. So small y represents capital Y minus capital Y bar. Similarly, small x1 represents the deviation of x1. So that is a capital X1 minus capital X1 bar. Okay. Similarly, for x2, so it is deviation x2. So it is the difference between x2 capital minus x2 bar capital. So then you have three different columns: x1 bar, deviation of x1 bar, deviation of x2 bar, deviation of x1, deviation of x2 and deviation of y. So now as per this requirement of this particular structure, so you have to calculate or you have to add another columns sequentially. So that is x1 into y is another column, x1 and x2 is another column, then x1 square is another column, then x2 square is another column, then x2y. So now once you have these columns, then finally you take a summation of all these columns, then accordingly apply, you will get the final matrix. Then after that, if you will solve that particular matrix, you can able to know what is beta 1 head, beta 2 head, and using this beta 1 head and beta 2 heads, you will get this, you can say beta 0 head. Beta 0 head equal to y bar minus beta 1 head x1 bar minus beta 2 head x2 bars. Okay. So x1 bar x2 bars you can directly assess from the original samples, because it is summation x1 by n and summation x2 by n. Okay. So now, so once you follow this estimation process, and after that getting this beta 0 head, beta 1 head and beta 2 head, so now we are position, or next step, we have to represent the information about the estimated model. So how you have to represent the complete information of the estimated model. So now, as usual bivariate structures, so here the moment you will get the estimated model, here like this. Okay. So y head equal to beta 0 head plus beta 1 head x1 plus beta 2 head x2. So this is our estimated model, where beta 0 is followed by this equation, and beta 1 head followed by this matrix, and beta 2 head is followed by this particular matrix. Okay. So now after getting all these values, estimated values for beta 0 head, beta 1 and beta 2 head, so then again you like to go for its testing. So that is what we call it the reliability testing. So that means here again our agenda is to know whether this particular estimated model is the best fitted or not. So now to know the best fitted model, or you can say good estimated models, so now we have to go for reliability test. So now there are two different tests here. So one test is with respect to specification test, and another is related to goodness fit test. Okay. So that means the structure is like this. So the moment you will get this equation, y head equal to beta 0 head plus beta 1 head x1 plus beta 2 head x2. So then your objective is to know whether this is significant, or this is. That means here we like to know whether they are significant. Okay, significant. So that means significant is a question mark here. So we like to test whether the parameters obtained by using the information and techniques are significant or not. Okay, so that means, so the moment, so there are in fact there are two specific objectives. First objective is to know the significance of estimated parameters, and second objective is to know the overall fitness of the model. Okay, so that means, so far as a best fit model is concerned, best fitted model, best fitted models, you have to know the best fitted models, you have to go for reliability testing. Okay, reliability testing means with respect to this estimated models. Okay, so now reliability testing has a two different specification here. One is called as a specification test with respect to parameters, specification test, and another is called as a overall fitness test. Okay, overall fitness test. So this specification test, this particular structure indicates the significance of the parameters. Okay, specifications test objective is to judge significance of the parameters. Okay, significance of the parameters. Then in the case of overall fitness of the models, here the objective is to know the overall fitness of the model. Okay, so this means this is otherwise known as, actually it's not overall fitness of the model, it's a goodness fit models. In fact, instead of putting overall fitness test, it's, you can say goodness of fit test. Okay, goodness of fit test. So that means we like to observe here overall fitness of the model, overall fitness of the models. Okay, overall fitness of the model. So this is how the second objective of secondary objective of this particular reliability testing. So now, so far as significance of parameter is concerned, so like our bivariate setups, so we have to apply here t statistics, and again in the case of overall fitness of the model, we have to use f statistics. Okay, so now this you need the t statistics, and this you need f statistics. Okay, so before we highlight the entire structure of this specification test and overall fitness of the models, let me first highlight the two different tables. One table is related to the estimated values. Okay, that means estimated information about all these parameters, and second table is, that is ANOVA table. So that is, which means that will indicate the overall status of the model or overall fitness of the model. So now here the estimated information will give you the indication about the exact influence of that particular variable to the dependent variable. That means what is the weightage of x1 on y and what is the weightage of x2 on y, and in the same times we have to see whether x1, the influence of x1 on y is statistically significant, and that is observed through beta 1 head, and similarly in the case of x2, what is the influence of x2 on y is significant or not. So that is observed through beta 2 coefficient, means significance of beta 2 coefficient. So now we have to see how quickly they are significant, or what extent they are significant. So that means we have to design in such a way, or we have to restructure in such a way that the parameters should be statistically significant at the highest level, that we can say that it is 1%. So that means the moment we have that type of objective or a specification, then obviously the overall fitness of the model, that is R represented by R square and followed by adjusted R square and tested by F statistic, should be also statistically significant at a 1% level. So that means in the case of Trivariate Econometric modeling, so we expect that the way we will design that particular estimated, we expect that the parameters with respect to beta 0 head, beta 1 head, beta 2 head should be statistically significant at least at 1% level, and in the same times the overall fitness of the model judged by R square and tested by F should be also statistically significant at 1%. If that is the case, then that that Trivariate model is, you can say, can be considered as a best fitted model and can be applied or utilized for forecasting or policy use. So now to go all these details about the specification, let me highlight here what is the estimated information about this Trivariate econometric modeling. That means what sort of things we need to have to go for this reliability test with respect to parameters and with respect to the overall fitness of the model. So let me highlight what is the sequence or what are the way we have to represent the final structure of the estimated models. So if you don't like to put it in a tabular format, you can put it in a also model format, or you can say equation format, and followed by it has to be structured in such a way that the entire tabular information means the entire estimated information can be, you can say, judge or establish through the equation, either through the equation or through the tables. So depending upon your interest or choice or observation, so you have to use any one. So that is not a hard and fast rule, but the structure or sequence, or you can say the representation of all these information should be very systematic, and as usual it will follow this structure and setup. So now y head is equal to beta 0 head plus beta 1 head x1 plus beta 2 head x2. Okay. So now this is the estimated model which we have derived from the original econometric models, y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus the u error component. After process or application of Euler's technique, we have received this beta 0 head, beta 1 head and beta 2 head, where beta 0 head has some statistical formula, beta 1 head has some statistical formula, and beta 2 head has some statistical, which we have already discussed. So now how we have to do go for, means how we have to go for this reliability part. So that means in the first so far the reliability of reliability testing is concerned with respect to parameters, then obviously we need to know what is the variance of all these parameters. Okay, so we have discussed couple of days back the term called as a BLUE, best linear unbiased estimators. Okay, so the term called as a BLUE, best linear unbiased estimators. Okay, so that means whatever beta 1, beta 2, beta 1, beta 2 head you have, so these estimated parameters should have some sample properties, means it should follow some sample properties. That means it is through BLUE theorem. So best linear unbiased estimators. The moment you will go to touch these theorem properties, then by the way you will get all these informations. Okay, so that means, so here you need variance of beta 0 head. Okay, this is known as variance of beta 0 head. Then you must have variance of beta 1 head. Then you must have variance of beta 2 heads. Okay, variance of beta 2 heads. So corresponding to variance of beta 0 head, you must have standard error of beta 0 head. Okay, then standard error of beta 1 head. Okay, then standard error of beta 2 head. Okay, so for corresponding to standard error, so you need to have calculated t statistics, t beta 0 head, t beta 0 head. Okay, then this is t beta 1 head. Okay, so this is t beta 2 head. Okay, this is t beta 2 heads. So now after getting this t beta 0 head, t beta 1 head and t beta 2 head are represented as a calculated t statistics. The moment you have calculated t statistics, so then as usual you have to compare with the tabulated statistic with the with the available sample information and with respect to the degrees of freedom, because the degree of freedom here is depending upon the sample observation and number of parameters in the system. Since in this particular setup, so here the representation degrees of freedom is represented as a n minus k. So here n represents number of sample, means sample size, number of sample okay, it's better to put sample size. Okay, this is sample size, and k represents number of parameters in the systems, or you can say number of variables in the systems. So that means in this particular sequence or in this particular problem, means in the trivariate structure, k represents 3, k represents 3 means since there are 3 variables in the system or 3 parameters involved in this estimation process. So now with the help on that means the number of parameters which is represented by k is known to us in this trivariate setup. So we have to just check it, what is the sample size. So with respect to sample size and with respect to degrees of freedom, we can have the tabulated statistic with different level of different probable level of significance. So accordingly, we are in a position to justify whether particular item is statistically significant or not. For instance, again we have to go for this, you know, one tail test or two tail test, right tail test, or you can say left tail test, like this. Okay, so this is how we have to receive this means we have to compare the setup. So let us assume that this is the critical region, this is accepted regions, this is accepted regions. So as usual, so this is the origin. So now if you go by, you know, two tail test, then you know this side is minus and this side is plus. So now we like to have first tabulated statistics. So let us assume that this tabulated statistics is 1.96a and this is minus 1.96a. So now now with this particular tabulated value, calculated value, then you have to locate where it can be possible to set. So now this is rejected region. So this is rejected region and this is also rejected region. So this is as usual, you know, very similar to bivariate analysis. The only difference is here the the matrix format, that is 3 into 3 orders, where in the bivariate format it is in the order of 2 into 2. So that is why it is a little bit complex and the formula is a little bit different to bivariate, but the structure setup is almost all same. So now the moment you have, then you just locate it, corresponding, you know, beta, more or less, because sample information is same, means obviously this, you know, significance, this tabulated statistic value will be more or less same. So you have to just check it, what is the calculated value of beta 0 head, beta 1 head and beta 2 head, that to t statistics. So now you represent accordingly. So now if it is coming this side or this side, then obviously you have to reject this null hypothesis. That means before you go for, you know, calculating all these t statistics, then you have to set the hypothesis, that null hypothesis, that the beta 0 head equal to 0, beta 1 head equal to 0 and beta 2 head equal to 0. Then we have to reject the null hypothesis that beta 0 is not 0, it has substantial or significant value which can build the, you know, build the fitness of the models, or that fitness of the model can be, you can say, used for forecasting or policy use. So now what we will do in the next step, so we will take a simple examples, then we have to go for this particular testing. So whether this, you know, means what, how quickly we can have this, or we can check the significance of the parameters for trivariate modeling, and in the same times how is the setup and structure of this ANOVA, that is analysis of variance. Since we have no time now, so this particular process we will do in the next class. With this we have to conclude this particular session. Thank you very much. Have a nice day.